readings. In this one, I'll be talking about resistance in parallel and how it is. It can be integrated in a very simple scenario inside the idea of a circuit. So let's say I have this circuit. This is the battery, and it has, let's say, 5 volts. All right, and then I have these three resistors plugged in parallel as follows. So like this. And one has 1 ohm, the second one has 2 ohms, and the third one has 3 ohms, or let's say the third one, so it's a little different, has 5 ohms, and then it continues and it goes back to the battery. And now what I want to figure out is, let's say, what is the current? Well, I know that I times R, so the current times the resistance is voltage. The 5 volts will equal whatever the resistance is times the current that I'm looking for. So I can derive that I equals V over R, right? But the problem is I don't have a single resistance now. I actually have to rewrite this. And the rule for resistance in parallel is as follows. These 3 resistors which are plugged in parallel, so basically this is the final question that I'm looking for while I'm doing all these steps. The final resistance, a way in order for me to rewrite this resistance and put it as a single item in the series configuration of this circuit. So just replace it all by just one resistor, which will, in this case, because it's the only thing on the circuit except the battery, be the entire resistance that I'm looking for in order to plug it into this formula alongside with these 5 volts. Well, in order to do it, in order to rewrite a parallel configuration of multiple instances of resistance of multiple resistors in parallel, I can use this equation. So the total resistance of the parallel thing, not like of everything, if there was more resistors here, of course that doesn't include, but it includes this part. So the total resistance of these 3 will be equal to the 1 over, let's say this is R1, this is R2, the middle one, the 2 ohms, and this is R3, the 5 ohms. So it's 1 over R1 plus 1 over R2 plus 1 over R3. So using these R1, R2, R3 resistances, I can reach the R total resistance using this equation. So 1 over the total resistance is 1 over one of them plus 1 over the other plus 1 until the last one in the parallel configuration is reached. This equation relates the equivalent resistance to these 3 in parallel together to the resistances of each of them. So I can continue solving this. So our total, which I'm looking for, is 1 over 1 plus 1 over 2, and the third one is 1 over 5. And now I can solve this. So I can. This is the structure. This is the scheme that I was using, and now I can just start simplifying it. So 1 over R total. I can start writing just R because I'll just need what these 3 will be replaced by in a second, but I'll just keep writing R total because I used it before. So this will be, I can get the common denominator as 10, so it's 10 over 10 plus 5 over 10 plus 2 over 10 as follows over 10, and that gives 17 over 10. So it's 10 over 10 plus 5 over 10 plus 2 over 10, right? And this gives 17 over 10. I will just say R for now. I will stop using total because it's the only thing that's left as far as R right now. So 1 over R equals 17 over 10. And now I just manipulate this in order to find the result. So the R is 10 over 17 ohms, the same unit. Okay. This is the result, and this thing is the equivalent resistance to these 3 resistors in parallel. So I can replace these 3 ones by just one, which will be on the circuit in series configuration, in series. So it's 10 over 17 ohms right here. Just one resistor replaces, or this equivalent circuit map now helps me finally realize that I can just take the resistance now, and when resistance is just in the series, I just add up the resistances. And now it turns out there's just one resistance, so the entire resistance of the circuit is the 10/17. So now I can finally calculate the current. Alright, so now that I know this, I know that I equals V over R, and that equals 5 volts. That's the voltage on the circuit over 10/17. Alright, so that equals ohms, and the result will be in amperes. So it is 5 times 17/10 amperes, which is 8.5. Alright, so this is the result. The current on this circuit will be 8.5.